important parts. The first thing you want to start with when you're graphing an ellipse, of course, is the center. And we find the center by looking at the equation we're given. The standard form of the equation for ellipse is x minus h squared plus y a squared, x minus h squared over a squared plus y minus k squared over b squared equals 1. And our center is hk, whatever's being subtracted from x and whatever's being subtracted from y. As you can see in this example, nothing is being subtracted from either of them. So our center is at 0, 0. Okay, so that's how you would start. Put your center on 0, 0. Then you would find a and b to help shape your ellipse. A squared is underneath the x. Okay, so a would be the square root of 25, or 5. B is under the y. The square root of 16 is 4. Okay, so our a is 5, our b is 4. So from our center for our x values, we're going to go 5 to the right and 5 to the left. These are our vertices. The largest number gives you your vertices. So since 5 was bigger than 4, that gave us our vertices. So our vertices are at 5, 0 and negative 5, 0. You can tell which direction your ellipse is going to go based on whether there's a larger number in the x's or a larger number under the y's. Okay, what do the b's do for us? That tells us kind of how far to go in the other direction. So from the center, if we go up 4 and down 4, that kind of gives us guidelines to draw our ellipse, since they were wanting us to graph that. Obviously, this is just a sketch, not even a great sketch. Okay, the focus point, we use C to find that. To find C, you take the square root of your a squared and b squared, do the larger minus the smaller. So in this case, it's going to be a squared minus b squared. 25 minus 16 is 9. And the square root of 9 is 3. So C is 3, and it's always going to be on the major axis. Okay, so whichever is larger, x or y. In this case, under the x was larger. So we're going to use in the direction of x. So 3 to the right and 3 to the left for our focus points of the center. So our foci, or our focus points, are at negative 3, 0 and 3, 0. The eccentricity for a horizontal ellipse is C over A. Okay, if this were vertical, up and down, it would be C over B. Again, you're just using whichever is larger, C over 5 in this case. So our eccentricity is 3 over 5, or 3/5. So we have graphed our ellipse and named all of those critical parts. Alright, here we go next. On graph paper, they want us to graph the ellipse, name all of those parts and pieces. We would want to see whether this is a vertical or horizontal ellipse, and we can see just by looking here that it's going to be vertically, because underneath the y, the 100, is larger than that underneath the x, which is just 64. So first we need our center. The center is our HK. Don't forget to change the sign when you write them down. Okay, because remember it's x minus h, so our h is actually positive 2. Our y would be negative 1. So we have our center at 2, negative 1. When we're graphing, we need to know a and b so that we can form our ellipse. A squared is underneath the x, so a would be the square root of 64, which is 8. B would be the square root of 100, which is 10. Okay, so vertically, again, we're going to go up 10 and down 10 from this center. And that will give us our vertices. Okay, so there's our vertices. Again, I didn't draw a real square on my graph. So where are my vertices? Notice the x value didn't change, only the y value did since this was a vertical ellipse. Okay, so it was a distance of 10, so if I do negative 1 plus 10, I get 9, the 0.29. If I do negative 1 minus 10, I get negative 11, the 0.2, negative 11. Let's use our b's to form our ellipse. The b we're going to take me right and left, 8, or excuse me, our a's, 8 to the right from the center, and 8 to the left of the center. So there's a basic picture. As you can see, I didn't do a great job of keeping my ellipse real square. Graph paper would have been much better. Guess that's why they have to use graph paper. The focus point is determined by C, and C in this case is the square root of b squared minus a squared. Again, always the larger minus the smaller. B squared was 100 and a squared was 64, straight from our equation. So we get the square root of 36, which is 6. Our C is 6. Again, you want to stay with the major axis was going up and down. So again, your x values are not going to change, just your y values, because this was a vertical ellipse. So if I take negative 1 and go up 6 or add 6, I get 5. If I take negative 1 and subtract 6 or go down 6, I go to negative 7. So my focus points, my foci, are at 2, 5 and 2, negative 7. Okay, I have graphed it. All I have left is the eccentricity, which is always equal to C over your larger value, which in this case is B. C over B would give me 6 over 10, or 3/5. Okay, if it's a vertical ellipse, your eccentricity is C over B, because it's always the distance from center of focus point over the distance from the center to the vertex. All right, here is our final example. So when you're graphing ellipse, the first thing you want to do is identify the center. In this case, it's at negative 3, 1. The next thing you want to do is determine whether this is going to go horizontally or vertically. And this is going to go vertically because the larger number, or excuse me, horizontally, and I missed with my pen at the same time, horizontally because the larger number is under the x value. Okay? So our A is the square root of 9, which is 3. Our B is the square root of this b squared here. Our B is the square root of 3. Okay, so there's our A and our B. Let's put our center on the graph and go from there. Our center is at negative 3, 1. Okay, to find our vertices, again, our A was the larger number is on our x, so it's going to go horizontally and by a number distance of 3. So we're going to go 3 to the right and 3 to the left of our center. And there's our vertices at, notice the y value doesn't change because we're going horizontally. So we end up with 0, 1 when we add 3. And when we subtract 3, we get negative 6, 1. There's our vertices. Okay. What does the B do for us? It tells us how far to go up and down to kind of form the ellipse. So let's find out what the square root of 3 is. It's about 1.7. So from the center, if we go up about 1.7, not quite 2, and down 1.7, okay, there is a picture of our ellipse, roughly. Not a great drawing. All right, focus point. We need C for that, so let's find C. C is the square root of whichever is larger. In this case, A squared was 9 minus B squared, which is 3. So C equals the square root of 6. So our focus points, we're going to go square root of 6 to the right and square root of 6 to the left, which if you want to put that on the graph, you can go ahead and find the square root of 6 is about 2.4. So we go 2.4 to the right of our center and 2.4 to the left of our center. There's our focus points. When you write those down, however, since the y is not changing, just the x is by root 6, you can write the focus points are at negative 3 plus the square root of 6, comma 1, and at negative 3 minus the square root of 6, comma 1. And what that does is gives you an exact number for your focus point instead of a rounded number. Okay. Finally, we have the eccentricity, which, again, eccentricity is going to be c over the distance from the center to the vertex. In this case, that was our a value. Okay, so c over a gives us the square root of 6, the distance from the center to the focus point, over 3, the distance from the center to a vertex. And there is our eccentricity, our center, our vertices, and our focus point.